Hello friends, today we are going to discuss hypothesis testing and confidence interval, and I will take some examples from transportation engineering. So let us first understand what a hypothesis is. Hypothesis tests are used to assess whether a difference in population parameter between two or more groups is likely to have arisen by chance or whether some other factor is responsible for the difference. And this population parameter can be either a mean or a variance, or it can be proportion also. Now take this example. Suppose it is required to find the impact of speed limit on average speed of vehicles on a road. So take the data before and after the change of speed limit and determine the average of the two set of data. Now the question is, how do we know whether these means or these averages are different or the same? Whether the observed difference in mean speeds between the periods is explained by the natural sampling variability or it is attributable to the change in speed limit. That is the hypothesis testing. So a hypothesis test is a method of statistical inference which typically compares data among multiple samples or between a single sample and a reference value of interest. Now, two statistical hypotheses are posed. One is called null hypothesis, assertion about the parameters, and it is denoted by H0, and alternate hypothesis, which is denoted by either H1 or HA. This is the assertion of all situations not covered by the null hypothesis. H0 generally takes the form no effect, no difference between the samples, or the process used at present is as good as the old one. So when we say two means, so null hypothesis assumes that there is no difference in two means. And H1 is opposite to that. H1 assumes that there is a fact. Now we should reject or accept the null hypothesis based on some statistical test. Test statistics used in many parametric hypothesis testing applications rely upon either Z, T or F distributions. So whenever a decision is based on the result of a hypothesis test, there is chance that it is incorrect. And therefore we must first define a level of significance. That is the probability of making error in accepting or rejecting a hypothesis. And there can be two types of error. Type 1 error is that we are rejecting H0 when it is actually true. And type 2 error is when you accept H0 when it is false. And we denote these errors by type 1 and type 2. So when you accept H0, when H0 is true, the probability of this error is 1 minus alpha. And when you accept it H0 when actually H1 is true, that means H0 is not true, then probability is beta, and that is called type 2 error. And similarly, when you accept H1 when actually H0 is true, then probability is alpha. That is type 1 error. And when you accept H1 when H1 is true, then this probability is 1 minus beta. So alpha is probability of type 1 error and beta is the probability of type 2 error. Remember, both errors cannot be minimized simultaneously. Fix one and minimize the other. So generally we assume alpha, value of alpha, that is the level of significance. Or you can say 1 minus alpha is level of confidence. There are two types of test. One is one-tailed test and other is two-tailed test. Now when you take a hypothesis like this, that null hypothesis is mu is equal to mu naught and alternate hypothesis is mu is equal to mu naught. Now the decision of whether null hypothesis is rejected or not is based on the rejection region. In hypothesis formulation like mu is not equal to mu naught, rejection area can be both sides of the distribution. either this side or this side, the positive side or in the negative side. This is when mu is greater than mu naught, and this is mu when mu is less than mu naught. So this is the area of acceptance. So if you take level of significance alpha, then you divide this alpha into two parts, one in the negative side and one in the positive side. And that is the rejection area. This is the rejection area on the positive side, rejection area on the negative side, and this is the acceptance area, which is 95% if alpha is 5%. When you take the assertion like this, that H1 is mu is more than mu naught, then this is the positive area, only in the positive area. So it remains alpha. Now here rejection area is this much only, and that is the acceptance area. So this is the critical value that we call Z value or T value, that if actual value of the parameter, actual value of a statistic is more than this value, then we reject it. Similarly, if the assertion of alternate hypothesis is that mu is less than mu naught, then it is on the negative side. So this is the two-tailed test, and these are one-tailed test. You can see the difference here. In two-tailed, you reject area on both sides of the distribution. In one-tailed, only on one side. The critical value of Z distribution for one-tailed test and two-tailed test are given in this table. For a level of significance alpha 0.1, 0.05 and 0.01, these are the values. Can be on positive side or negative side, and Z value is calculated using this equation. That is sample mean minus population mean upon standard deviation upon square root of n. N is number of sample. When sample size is small, when sample size is small, less than 25, then we take T distribution. Equation is same, only their parameters is different. Now it is indicated by S. So it is a 5-step process. The first step is state null hypothesis H0 and alternate hypothesis H1. Then choose a level of significance alpha. It can be 5% or 10%. Then choose the critical value of Z parameter or T parameter. Calculate statistic value of Z and T and compare and draw the inference. Let me take one example here. The question is, the average IQ of the adult population is 100 with the standard deviation of 50. Now this is the data from population. A researcher believes this value has changed over time, and he decides to test IQ of 75 randomly selected adults, and the average IQ is 105. Question is there enough reason to believe that the average IQ of adults has changed? Now this statement is important. IQ has changed. So it is a two-tailed test. Null hypothesis here will be that the average IQ is same. Mu is 100, and alternate hypothesis will be that it is not 100. So it can be larger than 100, it can be smaller than 100. So it is a two-tailed test. So second step is now define alpha. Alpha, let us take 5%. Then find out the critical value of Z distribution for a significance level of 5. And this two-tailed test, it is 1.96. So this is 1.96. Now you calculate value of Z. Z is calculated using this equation. X bar here is 105. That is the sample mean minus the population mean, that is initially 100, which is given, and standard deviation is 15. That is the population standard deviation divided by square root of n, 75. This value is 2.89. Now when you compare this 2.89 with critical value of 1.96, this value is larger, and therefore we reject the null hypothesis, and the suggestion of the researcher that IQ has changed is correct. Now let us take one more example. The speed limit on a highway is 100 km per hour. A traffic engineer believes that the actual speed of the vehicle is less than 100 km per hour. and therefore he takes the speed of randomly selected vehicles and get 69, 79, 89, 99 and 109 km per hour. So 5 vehicles are selected. Is the speed of vehicles is really less than 100 km per hour? That is the question. Now here when we say less than, then it becomes a one-tailed test. So it is on the now negative side. So here you assume alpha is equal to 5%. Calculate critical value. Now for degree of freedom 4, this critical value corresponding to alpha is equal to 0.05 is 2.132. Now you calculate value of t. Now t is given by this equation. Average speed of the 5 vehicles is 89 and the standard deviation is 15.81 and therefore this value is 1.56. Now you see the distribution. Here is the value of t and corresponding to 5%, here is the rejection area, that is t critical 2.13. Now this is the total area which is accepted area and therefore we should accept the null hypothesis because the t calculated is less than the rejection area, that is critical t 2.132, and therefore we accept the null hypothesis. The claim that speed is lower than 100 is not correct. Speed has not changed. Extremely useful application of statistics is comparing different samples or different groups. In transport engineering, for example, we frequently need to compare speeds, accident rates, payment performance, travel time, and many more such quantities. This comparing two means. Now here, when you are comparing two means of two samples, we calculate Z value, and Z value is given by this: the difference in sample means minus difference in population means divided by, that is the standard, the variance. S1 square and S2 square are the variances and N1 and N2 are two sample sizes. When the sample size is small, that is N1 and N2 both are less than 25, then this follows a t distribution, and t distribution or t value is calculated using this equation. The same equation, only thing is that in place of here population standard deviation, it is now sample standard deviation. And t distribution depends upon degree of freedom also, and degree of freedom is calculated using this equation. So we take the same example that speed limit is repealed on a highway. Does it make any difference of mean speeds? When you take 744 observations are taken before repeal of the speed limit and 552 sample is taken after repeal of the speed limit. Before repeal, the mu or the mean is 57.65 km per hour with a variance of 16.4, and after repeal the mean is 60.48 km per hour and variance is 19.1 km per hour. Now question is whether these mean speeds are same or different. So we make a hypothesis that the means are same. There is no difference in means, and alternate hypothesis is that they are different. Mu A minus mu B is not equal to 0. So it becomes a two-tailed test. And because sample is large, so we go for Z value. So calculate Z value using this equation, and that is 60.48 mu A minus 57.65, and this is 0 because before speed limit was repealed, there was no difference in two means, the same, and that is the value of denominator, and that is 11.89. Now with this 11.89, we compare this value with ZC, that is critical value, corresponding to alpha is equal to 0.05. Now this is 1.96. So if you take this distribution again, this is the critical value 1.96 on both sides because it's a two-tailed test. and this is the area which is acceptance area. Our value, calculated value is 11.89. So it lies beyond this area and therefore this rejection area. So we should reject the null hypothesis. That means means are not same. The repeal of speed limit has changed the mean speeds. Now if you are interested how much change has occurred, then you find out the range or confidence interval. Confidence interval for a z distribution is given by this equation. Difference in the means plus z value multiplied by square root of variance upon NA plus variance of B upon NB. So if you calculate this value 2.83 plus 1.96, the square root of these values, this is 2.36 and 3.29. So you can say that with 95% confidence level, the increase in speed after repeal of the speed limit is between 2.36 and 3.29 km per hour. Now, many times our interest is not in the averages, not in the means, but we are interested in the variance. And if you compare the variances, F test is used. And this F statistic calculated using this equation, that is the variance of the first population and variance of the second population. The degree of freedom for this statistic is n1 minus 1 and n2 minus 1. Now, if you are comparing two variances, then greater variance is placed in the numerator and degree of freedom will change accordingly. And here also you can make null hypothesis that two variances are same, and alternate hypothesis can be that they are different, less than, more than, or not equal. So this is one-tail test. This is also one-tail test, but this is lower one-tail test. This is the upper one-tail test, and this is a two-tail test. Same example, that speed limit is repealed on a highway, and we take after repeal and before repeal data, and variance of these data is 16.4 km per hour after the repeal of the speed limit and 19.1 km per hour before repeal of the speed limit. We are not now keen to know the difference between the mean, but we are interested now to find out difference in the variance. So we again make the null hypothesis that there is no change in the variances, and alternate is that they are not equal. So it is two-tailed test. So if you calculate F value by putting larger variance in the numerator, its value is 1.16. And degree of freedom here is 522 and 744. And that is the maximum limit of any degree of freedom. And therefore, critical value of F corresponding to alpha is equal to 0.05 is 1. So this value, critical value, is smaller than calculated value, and therefore we reject the null hypothesis, and there is a difference in variance of data taken before and after repeal. Now, so many times we need to compare the data in a paired form, and that is paired t-test. It is used when dependent sampling is done from a normal distribution. There may be correlation between specific observations in the two samples being compared. For example, when you observe individual repeatedly over time, there is a strong positive correlation between the two samples being compared. Then we use paired t-test. And here the parameter of interest is the difference in means between the two populations. And this t value is calculated using this equation. That is the difference in the means, and that is the sample standard deviation of these differences. Let me explain this test with the help of one example. Let us say there are 10 intersections in a city which are experiencing a high number of rear-end collisions. And to reduce these collisions, the signal timings were changed. And these are the crashes before and after implementation of the changing timings. X1 are before implementation and X2 are after implementation. So question is, whether there is any change in the number of crashes after timing adjustments. So let us take the null hypothesis that there is no change. That means the difference in average of two set of data is 0. And alternate hypothesis is that there is a change. So let us calculate the mean and standard deviation of differences. So in this table, if you add one more column here, and is a difference between the two, x1 minus x2, total is 18, and therefore mean of differences is 1.8 for 10 number of data. And if you calculate the standard deviation, it will be 1.55. N is 10, and therefore you can calculate the value of t, that is 3.67. Now for alpha is equal to 5% and degree of freedom 10 minus 1, that is 9, the value of tabulated t is 1.833. And this 1.833 is smaller than 3.67. That means 3.67 lies in the area of rejection. And therefore, we reject null hypothesis. That means there has been improvement in the number of crashes after introduction of new timings. Number of crashes have reduced. So friends, thank you very much for watching this video. You can write your suggestion in the comment box.